Hello and welcome to another episode of CSEC Math with Sir Kumar. In our previous video, we looked at volume and total surface area. Just a quick reminder, what is volume? Remember, volume is the space that is enclosed by the boundaries of a three-dimensional shape, and surface area would be the area of all the surfaces outside of the shape. We looked at the cube, the cuboid, the cone, and the sphere already. In today's video, we would move on with the final two solids, and that would be the cylinder and the wedge, or what we call the triangular base prism. We would look at the formula to find the volume and the total surface area for those two shapes, and then we're going to go into examples and apply the formula to solve some other questions. So get your books, pens, calculator, and let's get into it. So in today's lesson, the first shape we're going to look at is the cylinder. So you have a cylinder here, and if you don't know what a cylinder looks like, just imagine any tin in the house, like a tin of mackerel or corn or mixed vegetable or any one of those things. That's a cylinder. So here you have a drawing of the cylinder. In order to find the volume is equals to pi r square h, and TSA, if you could remember the abbreviation, TSA is total surface area, and the total surface area is 2 pi r into r plus h, where r is the radius and h is the perpendicular height. Remember, again, the perpendicular height is the one that comes straight down, and when it reaches the radius, or if it's given outside, it forms a right angle. So two things we need: the radius and the perpendicular height. So we have an example here. Calculate the volume and total surface area of the shape below. So when you look at this shape, you have two measurements there. The one up here is called our radius, so this r, and the 5 is our height. So now let's use these values and substitute them into the formula and find the volume. So V is equals to pi, which is 22 over 7, multiplied by r squared. That means the radius times itself 2 times. So that's going to be 3 times 3 multiplied by the height. Let me just add cm here. The height, which is 5 cm. Make them into fractions. We put them over 1. So V is equals, we multiply all our numerators. That's going to be 22 times 3 times 3 times 5. And that's going to give me 990 cm cube divided by all our denominators. 7 times 1 times 1 times 1 is 7. 990 divided by 7 is going to give me 141.4 cm cube. And this is the volume of the shape. Now let's go and find the total surface area. So total surface area, the formula is 2 pi r into r plus h. Let's start substituting our values. So we have 2 multiplied by pi, which is 22 over 7, multiplied by r, which is 3 cm, into r, which is 3 cm, plus h, which is 5 cm. We put these over 1, make them into fractions. So let's start simplifying. So you have 2 times 22 times 3 is going to give me 132 cm divided by 1 times 7 times 1 is 7. Bracket means to multiply, so I'm just going to put a multiplication sign here. 5 plus 3 is going to be 8. And this is cm. So we put this over 1. 132 divided by 7 is going to give me 18.9 cm multiplied by 8 cm, and 18.9 times 8 is going to give me 150.9 cm squared. Remember, area is in squared units and the volume is in cubic units. So this is how you find the volume and the total surface area of a cylinder. Now, when looking at cylinder, there is one more thing that we have to find. So we're now going to look at an example of how we find not the total surface area, but there is something called the curved surface area. In our previous example, we looked at the volume and the total surface area of the cylinder. Now, here I have another formula, and it's the curved surface area. Now, the curved surface area is equals to 2 pi r h, where r is the radius and h is the perpendicular height, same as the formula before. Now, what is the curved surface area? Let's say, for example, you have a tin. The part that is going around the tin, or the face that is going around, is what we call our curved surface. Exclude the top and the bottom. This would be everything that's going around. So to find the area of the curved surface, we usually use 2 pi r h. So here you have an example. Calculate the curved surface area of the shape below. You have 6 cm and you have 10 cm. Our formula asks for the radius. In this example, they give us the diameter as being 6. So we have to first find what is the radius. Remember, the radius is half of the diameter. So if the diameter is 6, then r is equals to 3 cm. So now that we know what is r and h, let's substitute our values and solve for this. So this is going to be 2 multiplied by pi, which is 22 over 7 multiplied by r. That would be 3 cm. So let's put this over one time. Multiplied by the height, which is 10 cm. So we multiply all our numerators. 2 times 22 times 3 times 10. And that's going to give me 1,320 cm squared divided by multiplying all our denominators. We're going to get 7. So 1,320 divided by 7 is 188.6 cm squared. Remember, 2 pi r h is for the curved surface area. So if they ask you for the curved one, you use 2 pi r h, and if they ask you for the total surface area, then you use 2 pi r into r plus h. So that's the only this is the only additional formula that you have here. So you have the volume formula, the total surface area formula, and the curved surface area formula. Let's look at another example of volume of a cylinder. Now, if you notice here, our shape is a bit different because this one, it's an application question. So calculate the volume of the space between the two cylinders. So let's say we're trying to make a mold, right? And you have an outer cylinder and then you have an inner cylinder. They want to know how much stuff we have to put between our two cylinders in order to fill the space. The height is given as 13. So let's find the volume of the space between our two cylinders so that we could know how much stuff need to go in to fill our molding. So the first thing we're going to find is the volume of our outer cylinder. So the outer cylinder, and if you can remember the formula for the volume of a cylinder, that would be V is equals to pi r square h. The 16 cm that is given here would be the radius, and we have a height of 13. So let's substitute. V is equals to pi, which is 22 over 7 multiplied by r squared. That's going to be 16 times 16 times the height, which is 13 cm. Oh, cm, cm, cm. So we put them over 1 to make them into fractions. V is equals to, we multiply all our numerators. That's going to be 22 times 16 times 16 times 13. And that's going to give me 73,216 cm cubed divided by 7 times 1 times 1 times 1 is 7. So the volume is 73,216 divided by 7, and that's going to give me 10,459.4 cm cube. This is the volume of my outer cylinder. That's the bigger cylinder, right? Now let's look at the inner one, the smaller cylinder. Now they didn't give us the radius of the small cylinder, but they gave us the radius of the space, the distance, the length of the space, sorry, between our two cylinders. So if coming from the center to the outer one is 16 and the space between the two is 4, then we could find the radius of the inner cylinder. That's going to be 16 take 4, and that would give me 12 cm. So the radius of our inner cylinder is 12 cm. So let's go and calculate the volume of the inner cylinder. So again, the formula V is equals to pi r square h. V is equals to pi, which is 22/7 multiplied by r square. We just found r to be 12 centimeters. So that's going to be 12 cm times 12 cm multiplied by the height, which is 13 cm. Make them into fractions, we put them over 1. V is equal, so we multiply all our numerators. That's going to be 22 times 12 times 12 times 13, and that's going to give me 41,184 cm cube divided by our denominators would give me 7. The volume is equals to 41,184 divided by 7 is 5,883.4 cm cube. So the outer cylinder is 10,459.4 cm cube and the inner cylinder is 5,883.4 cm cube. Remember when we did compound complex shapes, we said that to find the area of the shaded region is usually the bigger shape subtract the smaller shape. Well, in this case, it will be the volume of our bigger or the outer cylinder subtract the volume of our smaller cylinder, the inner cylinder. So the volume of the space between is equals to the outer cylinder, which is 10,459.4 cm cube, subtract our inner cylinder, which is 5,883.4 cm cube, and subtracting them, I would get 4,576 cm cube. And this is the volume of the stuff that we would need to pour into our molding to make this shape. So remember, it's the outer cylinder, then the inner cylinder, and you subtract the inner one from the outer one, and you get the volume of the space between. The last shape we're going to look at is the wedge. So the volume of the wedge, or it's known as the triangular base prism. A lot of persons just call it the wedge. So in order to find the volume, volume is equals to AL, where A is the area of the cross section. Now, what does this mean? The area of the cross section. If you look at this shape, at this end, we have a triangle, and at this end, we also have a triangle. So if I'm to cut this shape anywhere along its length, then the face that we have here is going to be the same face we're going to get no matter where we cut the shape. So each one of these faces, as we cut, is the cross section. So the area of the cross section. Now we have a triangle here, and if you could remember from our area lesson, there are 3 ways to find the area of a triangle. So you have to look at what is given to you. If they give you the base and the height, then you obviously is going to use the half base times height formula. Or if they give you the length of all three sides, then you have to go and use the Heron's formula. So after calculating the area of the face, we then have to go and multiply it by our length, which is the lateral length. So to find the volume, it's the area of our face multiplied by the length. And the total surface area, you have two ways of doing it. The first one is BH plus PL, where BH is the base times the height and PL is the perimeter of the cross section times the length. Now we can use BH plus PL once we're given all three sides and the height, because we would need the height here and we would need all three sides to find the perimeter of this face. And the second method of finding the total surface area is what we call the front plus back plus bottom plus two triangles. If you look at this shape, we have one face here, one at the back and one at the bottom. And our three faces are rectangles. So we find the area of our front face plus the area of the back face plus the area of the bottom face, and then we add the area of our two triangular ends in order to find the total surface area. So we use this when we don't have the height. We just have all three sides and we don't have the height, then we use this one. So there's a lot going on in the formula. So let's look at some examples and how we use everything here to find our answer. So you have an example here, and if you look carefully, we have 1, 2, 3. We're given this side is 4, here is 5, and here is 5. And we're also given the height as 3 cm. You have the length as 15 cm. So if you're given the base and the height, then we would go straight into using half base times height to find the area of our cross section. So V is equals to AL. So area of the cross section. So we said that we're going to use the half base times height formula. So A is equals to half of BH. A is equals to a half. Our base is 4 cm multiplied by the height, which is 3 cm. A is equals to a half of 4 times 3 is going to give me 12 cm squared. A is a half of 12 is 6 cm squared. So since we found what is A, let's now go and find the volume of the shape. Therefore, V is equals to A times L. We found A to be 6 cm squared multiplied by L, which is our length, and that's going to be 15 cm. 6 cm squared times 15 cm is going to give me 90 cm cubed. And this is the volume of the wedge, given that we have the base and the height. Now let's go and find the total surface area. Again, we inspect. In order to use the BH plus PL formula, we must know the base, the height, and we must also know all three sides of the triangle. So we have the base, the height, and we know the length of the other two sides. So we're going to use the BH plus PL formula. So the total surface area is equals to BH plus PL. We found the base, or we're given the base as 4 cm. So that's going to be 4 cm multiplied by the height, which is 3 cm, plus the perimeter of this face is going to be the sum of all the sides. So that's going to be 5 cm plus 4 cm plus 5 cm multiplied by L, which is our length, and that's 15 cm. So let's simplify. 4 multiplied by 3 is going to give me 12 cm squared plus, in here we have 5 plus 4 plus 5, and that's going to give me 14 cm multiplied by 15 cm. This is 12 cm squared plus 14 times 15 is going to give me 210 cm squared. 12 plus 210 is going to give me 222 cm squared. So we use the BH plus PL once we know three sides, the height. Now, let's say you want to just verify if your answer is correct. Remember I said you could just add up all the faces and find the total surface area. Let's just do a quick check. So let me put a box here. So the front, the back, the bottom, and the two triangles. Now the front, that would be in front of the shape, we have 5 and we have 15. So the front is going to be 5 cm multiplied by 15 cm. The back would be this one, which is 5, and straight across, that's going to also be 5 cm multiplied by 15 cm. The bottom is going to be here 4 times 15. So that's going to be 4 cm times 15 cm. And the two triangles, we have to get the area. But since we already found the area to be 6, we're just going to use it from here. So this is going to be 2 multiplied by 6 cm squared. So 5 times 15 is going to give me 75 cm squared. Same for this one. 4 times 15 is going to give me 60 cm squared, and 2 times 6 is going to give me 12 cm squared. Adding 75, 75, 60, and 12 is going to give me 222 cm squared. So even though you have the base and the height, even though you have the height on all three sides, you could use this formula, or you could resort to this one. Whichever one you want to use to find the total surface area, you're going to get the answer. But just remember that in order to use this, we must know the height, and to find the perimeter, we must know all three sides. Let's look at another example. So calculate the volume and total surface area of the shape below. Now, if you notice with this one, we don't have any height. We're given the length of our three sides and the length of the shape. Now, remember when we have our three sides, we have to use the Heron's formula to find the area of the triangle. So the first thing we have to go and find what is A. So the area of the cross section, remember this one here, we're going to use the Heron's formula. So if you could remember, the Heron's formula is S is equals to A plus B plus C divided by 2, and then we further have the square root of S into S minus A, S minus B, S minus C. All right, oh, this should be A. So let's start. So the first thing we have to do is find what is S. So S is equals to A plus B plus C, and A, B, and C are the faces of our triangle. So that's going to be 6 plus 5 plus 7. So 6 cm plus 5 cm plus 7 cm divided by 2. And that's going to give me 18 divided by 2. And here we have 9 cm. So our S value is 9 cm, or the semi-perimeter is 9 cm. Now we have to substitute S into our formula here. So A is equals to the square root of S into S minus A, S minus B, S minus C. A is equals to the square root of 9 cm into 9 cm minus A, which we used as 6 cm, 9 cm minus B, which we use as 5 cm, and then 9 cm subtract c, which we used as 7 cm. So A is equals to the square root of 9 cm into 9 take 6 is going to give me 3 cm. 9 take 5 is going to give me 4 cm. And 9 take 7 is going to give me 2 cm. A is equals to the square root of, we multiply everything here. So 9 times 3 times 4 times 2 is going to give me 216 cm, and there's 4 of them, so it's to the 4th power. Just ignore the power for now. So A is equals to the square root of 216, and that's going to give me 14.7 cm squared. So we found what is A here, but this is not the end yet. We still have to go and put this and multiply it by our length to find the volume. Therefore, volume is equals to AL. Volume is equals to A, which we found to be 14.7 cm squared, multiplied by L, which is the length, and that is 18 cm. Volume is equals to 14.7 times 18, and that's going to give me 264.6 cm cubed. So this is how you find the volume of a wedge given the 3 sides. Remember, once you have the 3 sides, you have to go and use Heron's formula to find the area of the cross section. Now let's go to our total surface area. Let me just put the line here. Good. Now looking at this, we don't have any height. So we cannot go and use the BH plus PL formula because we don't know what H is. So we have to go the regular way of using the area of the front plus the area of the back plus the area of the bottom plus the area of the 2 triangles. So let's start listing them. The front, the back, the bottom, and the 2 triangles. So if you look at the shape, the front, we have 7 and then we have 18. So the front is going to be 7 cm times 18 cm. The back would be here. That's going to be 6 multiplied by 18. So that's going to be 6 cm times 18 cm. And the bottom is going to be 5 multiplied by 18. So this is 5 cm multiplied by 18 cm. The 2 triangles, we found that the area of the triangle is 14.7 cm. So we're just going to use it from here instead of doing it all over again. So this is going to be 2 multiplied by 14.7 cm squared. Multiplying them, 7 times 18 is going to give me 126 cm squared. 6 times 18 is going to give me 108 cm squared. 5 times 18 is going to give me 90 cm squared. And 2 times 14.7 is going to give me 29.4 cm squared. Adding it up, 126 plus 108 plus 90 plus 29.4 is going to give me 353.4 cm squared. And this is the total surface area of this wedge. Remember, if you don't have the height, you go to find the area of the front, the back, the bottom, and the 2 triangles. And again, if you don't have the height, you have to resort to using Heron's formula to find the area of the cross section and then multiplying it by the lateral length or the length of the shape to find the volume. So this brings us to the end of volume and surface area of solids. In today's lesson, we looked at the cylinder and the wedge, or we call it the triangular base prism. Remember, in the cylinder, you have three formula: the volume, the total surface area, and the curved surface area. The total surface area would include the curve and the top and the bottom. And the curved surface area is only the curved face around the shape. When looking at the wedge, remember the volume is the area of the cross section, and we have the cross section as a triangle. So when you're given the base and the height, remember we use the half BH to find the area of that cross section. And also, if we have the three sides, we use the BH plus PL to find the total surface area. Or if you have the triangle with the three sides alone, then the area is going to be the Heron's formula, which is S is equals to A plus B plus C divided by 2, and then further A is equals to the root of S into S minus A, S minus B, S minus C. And for this one, the total surface area would be the area of the front, the back, and the bottom, plus the two faces at the end. So whatever is given, you would have to see that and apply which one of the relevant formula in order to find the volume and total surface area of the wedge.